your given side and wanted side, and we can start with given particles or grams or liters. And we so far broke down what particles are in this triangle. So we said particles can be molecules, formula units, or atoms. And for us to go from particles to moles, we have to use a certain number. Does anyone remember what that number is?
6
Good. So whenever we're converting from molecules to formula units to atoms, we have to convert them by using what we call Avogadro's number. I never told you guys what it meant, but the number value itself is 6.02 times 10 to 23. So this means that whenever you're going from given particles and you want to convert to given moles, you have to use 6.02 times 10 to 23. In other words, if you have this certain 6.02 times 10 to 23 molecules or formula units or atoms, how many moles can you have? 1. This is always going to equal to 1 mole. 6.02 times 10 to 23 of any of these will always equal 1 mole. And same thing on the other side. 1 mole of the wanted moles will always equal 6.02 times 10 to 23 molecules, formula units, or atoms. Now let's switch gears to grams. If you have grams and you want to find the grams of wanted stuff, can you go directly from given grams to wanted grams? You have to convert it first to what? The moles of given, and then convert that to moles of wanted, and then go to the wanted grams. How do we convert from grams to moles? Using what? You have to use a periodic table. So this number comes straight from the periodic table. The biggest problem that I've seen so far is that people don't remember how to find the molar mass of things that are complicated. So for instance, if you have something like this, we're going to find the mass of N, and then add that to 4 times the mass of hydrogen, which ends up being 18. Pretty simple so far, right? That's a really good one. What if you have something more complicated? What if you have 3 of those? Well, that distributes in. Just like in math, whenever you have a parentheses, you distribute the 3 into the parentheses. So you end up having 3 times the mass of nitrogen plus 12. So this multiplies, not add, times 1. And that will give you the mass of NH43. Does that make sense? Okay, so whenever you have a parentheses, it multiplies. Alright, so again, when we're going from mass to moles, we use the numbers from periodic table. So go ahead and write that down. Make sure you have all the bridges filled. Now, we've also learned how to convert from liters to moles. Does anyone remember the number? 22.4 liters for every how many moles? 1 mole. So I'm going to go ahead and highlight these paths. Oh, that's not the color I want. Change that to yellow and change this to green. So what that means is that if I have certain mass of a compound, that's always going to equal to 1 mole. If I have 22.4 liters of some gas, I'm always going to also have 1 mole. So what that means is that if I have any of these starting points, I simply need to convert them to moles using one of these bridges. But once I get to the given moles, I need to switch sides to the wanted side, right? How do I do that? I use what? I have to use the coefficient. So, important thing here is that you must first balance the equation before you use coefficient. But understand that you do not use coefficients going from these to moles. But you only use coefficients going from this given moles to wanted moles. A generic equation looks like this. If you had given unit, let's say moles, you're always going to have the same given unit at the next fraction, but at the bottom. But what are you going to have at the top? The wanted unit. Okay, some people ask me, okay, I know that I'm supposed to use this, but I don't know which one goes to the bottom of the fraction. Well, let the units guide you. If this is a given unit, this has to also be the given unit. And whatever unit you're looking for is at the top. Make sense? Alright, let's do an example. Oops, let's erase everything. Okay, so this is on the back of your map. It says N2 plus 3H2 yields 2NH3. It's already balanced, they already gave me the equation. Now it says, if 7 moles of nitrogen react, how many liters of ammonium gas will be produced at FCP? Let's write out what we're trying to go to. We're starting where?
With 7.
We're starting with the moles of nitrogen, so which is given, right? And then I'm trying to find what? The liters of ammonium. So if I were to go back to my map, let's draw our path. Where am I starting?
7.
No, where am I starting on the map?
Given the volume.
I'm starting at given moles. If I'm starting at given moles, and I'm trying to get to where?
Wanted moles.
Wanted what? I'm trying to get to here. So let's look at our path. I have to start from given moles, and then go where? I have to go to the wanted moles, and then what? And then I have to go to the wanted liters. So this is my path. I'm going to start with what? Good. So I have to start with what's given to me, which is 7 moles of N2. If I have 7 moles of N2 here, my next one has to have what at the bottom? Moles of what?
Nitrogen.
N2. Now remember, I asked you to write the generic equation down, right? If you got given moles unit here, what's the unit at the top? So what do I want this to become? Moles of ammonium. I can't go straight to liters, so I have to make a pit stop at the moles of the wanted guy. Now, let's fill out the numbers. For how many moles? For how many moles? By the way, where do I get this number from? That's the coefficient, right? Because remember, it's the bridge between the two sides. If I'm going from one side, which is given side, to wanted side, I have to use the coefficients directly out of the equation. Yeah?
This is different from what we were doing like yesterday and stuff, right?
It's just a little bit different, but it's the same concept.
We had a coefficient right there.
Yeah, we did. We always had coefficients. Alright, so what is the number of moles at the bottom?
1.
1. How about moles of NH3 at the
2.
bottom? 2. We get this straight from the coefficients, right? So if I'm here, did I cross over on my map? I did. I just crossed over to the NH3 side, right? Because look at what cancels out. This cancels out and that cancels out. So now I'm on the NH3 side, which is my wanted unit. So I'm now crossing the bridge. I'm already on the other side. Now, am I done?
No.
I still need to make my way to which side?
Liter.
The liter side, right? So I still need to take my moles of NH3 and take it to what? I need to go to liters, right? So what's the unit at the bottom going to be? Moles of NH3. And what do I want at the top? Liters. How many liters? How many moles? 1. Because remember, going from the side area, where it's triangle, circle, and square, to go to moles, it's always going to be 1. The only time you use the coefficient is when you're switching sides. We're not switching sides, we're still on the NH3 side. So I got for every 1 mole, 22.4 liters. Let's see how I put it in the calculator.
313.6.
So I'm going to go ahead and put everything in the calculator by putting 7 times 2 times 22.4 liters.
313.6.
And I get 313.6. Now, 313.6, but at the bottom it's just going to be 1. So my answer is going to be 313.6 liters. Of what?
NH3.
Absolutely. Now, since since you guys have been doing this for quite a while now,
We're not going to take a test.
we're going to do another problem, but I want you to do this on your own. I'll give you 15 minutes, work with the part.
Okay.
Gentlemen, let's get started. It says, if in a beaker, potassium reacts with magnesium bromide to produce potassium bromide and magnesium metal. If 75 grams of magnesium bromide reacts, how many atoms of magnesium are produced? So
Can I
first
walk
things
you through
first, what do I do?
Put 75.
I need to do what first?
Put what you have.
I
You're
need
given.
to write a reaction out. I need to write my reaction out.
We ain't got time for that.
Okay, so I'm starting with potassium. Magnesium bromide ends up being MgBr. Whoa, hello. MgBr2 because Mg is positive 2, Br is negative 1. Okay, it says it's going to produce potassium bromide. Potassium is K positive 1. Br is minus 1. So it ends up just making it KBr. Then it's just going to give you also the magnesium metal, which is just Mg. Now we start with what's given. It says 75 grams of magnesium bromide react. So, look onto your math. If I'm starting with the grams of what's given to me, where do I need to go next? Moles of what? Moles of what I'm given. So, let's balance it. 2, 1, 2, 1. I'm going to go from grams to moles of my given. Then I'm going to switch sides to moles of what I want. And then I'm going to go to the atoms. Yep. Okay, I'm starting with 75 grams of MgBr2. If I'm converting this to moles, James, what goes at the bottom of this fraction? Grams of what?
MgBr2.
Absolutely. When do I get that number from? Good. So G of MgBr2 goes at the bottom. At the top is what? Mole of what?
1. MgBr2.
And then there's 1 mole because every time you go from grams to
moles
on the same side, the mole gets 1. So grams ends up being 184.11 grams. Now let's cancel out what I know I can cancel out. Grams of MgBr2 cancels out with MgBr2, and I end up at moles of MgBr2. Now on the map, I'm exactly right in front of the bridge that I can cross to go to the other side. Right? Do you understand where I'm at? Yes. Now, if that's the case, if I need to cross the bridge to the other side, what information can I use next?
The coefficient.
I have to use the coefficient.
Yeah.
So for me to use the coefficient, what's the unit at the bottom of the fraction? Moles of? Moles of MgBr2, and then I have moles of what? Because that's what I'm looking for, right? So I have to put moles of Mg. Where do I get this number, Jamal?
My name's Jamar.
Equation. So I get 1 to 1. This is what I get. Let's go ahead and cancel out the units. Moles of MgBr2 goes away, and I get moles of Mg. Now I'm already on the other side, but am I done here? No, there's one more thing I have to do. I have to take the moles of Mg to what? Atoms. So if that's the case, what do I need at the bottom of this? I get moles of Mg, and at the top I need?
Atoms.
Good. When you do the math, you get this. 2.4 times 10 to 23. If you rounded it down or didn't round, that's fine, as long as your answer is correct. Does anyone need to see me put this in the calculator? Yeah. Okay. So if I were you, this is what it looked like. I would put everything on top in the calculator. So, 6.02. Oh, this is terrible.
We put everything in the calculator one time, then it would be right. If you try to divide it.
Okay, here's the problem. I know, I don't have a scientific, is this it? No. Okay, so I can't do scientific calculator on this, but do me a favor. When you put this in the calculator, you need to put parentheses around 6.02 times 10 to 23 all the way. Alright, now, last thing. I would like for you to work out this problem. It is a harder problem, but go ahead. The key information is that this is a combustion problem. So, sugar, which is C6H12O6, combust. If something's combusting, what's on the product side? Good. But what else do you need in the reactant side? There's your reaction. Balance it and solve it. Alright, let's work it out, guys. Guys, let's work it out. Give me a sec. I'm gonna work it out. Ah! Alright. So remember, C6, H12, ladies. Cut it out. Cut it out. Let me talk. Shut up! Yes, I am. O6, and we said that's O2, giving you CO2 and H2O. Okay, Stephen, tell me the coefficients. Okay, good. So 1, 6, 6, 6. Now it's balanced. I'm starting out with 9.46 grams of carbon. I'm going to convert that to what? I'm going to go from grams to moles by doing 12 grams of carbon is equal to 1 mole of carbon. Now I'm ready to cross the bridge. I'm going from carbon to carbon dioxide, CO2. So it's 12 plus 16 times 2, right? Right? Because it's carbon dioxide. So 12, what is it? 44 grams of carbon dioxide gives you 1 mole of carbon dioxide. I'm trying to find an oxygen. So here's oxygen, O2. For every 6 moles of CO2, I have 6 moles of O2. Now I'm trying to find the mass of the oxygen. Remember, it's diatomic, so I need to multiply the mass of one oxygen by 2, and I get 32 grams over 1 mole of oxygen. Multiply it out, and you get 6.88 grams. Okay, yeah, Jasmine.
On the bottom, after you do,
Why do you